without further ado, I'd like to introduce our speakers for today. Luis Acosta, who is going to be handling the presentation, has over 17 years of international experience in the oil and gas industry with Shell. He currently works in the Data Science Division at Canada Border Services Agency. Anton is going to also be in the background, who is going to help Louis in answering questions. He currently works as a data scientist at Energy Toolbase. He has 6 years of experience in developing, monitoring, and managing machine learning models. Over to you, Louis. Yeah, you can start your presentation.
Okay, thank you, Emmanuel. I'm going to be sharing my screen now. Can you guys see my screen now?
Yes, we can. Yes.
Okay, perfect. Okay, hi everyone. Thank you so much for joining us today. And thank you especially to the SPE Calgary, the Young Professionals group for organizing this event. I'm very glad to be here. Just before I start with the presentation, I thought I might share a bit about myself and my journey into data analytics. My name is Luis Acosta. I am a petroleum engineer by background, and I'm currently in this adventure of transitioning my career from petroleum engineering into data science. I worked for over 15 years at Shell in different reservoir engineering roles. And I came to discover data analytics when I started working in Shell about 10 years ago. For many years before that, I had done forecasting in conventional fields using reservoir simulation models, analytical models, decline curve analysis. But when I started working in Shell, I found myself spending more and more time looking at big data sets, hundreds, thousands of wells, with the help of software like Spotfire, Power BI. From studying the impact of well length, completion designs, well spacing, finding sweet spots. As I grew more and more interested in this area, I started taking courses on my own and eventually signed up for the evening program at the University of Calgary in Data Science and Analytics. And I'm very glad this year I actually continued and finished the master's degree. And I recently started with my first position as a data scientist working in the government. Definitely one of the stepping stones in this journey, it has been the opportunity of participating in projects like this one, the mentorship program. One of the big wins for me about this project, it was the opportunity of applying data science skills on a problem and actually working instead of just studying or working on my own, actually the opportunity to work in a team, and especially having someone so experienced like Anton, a mentor, who would help you when you get stuck. So this was a great opportunity, and I'm very grateful for the SPE for organizing this type of event. So today, now getting into the matters, what I'm going to be showing you today is the project that we did earlier this year, which is about how we apply data analytics to look at the impact of COVID-19 on air quality. So the central question we asked ourselves, it was, where has the air quality improved the most during the pandemic? This is a topic that actually was suggested by our mentor, Anton, and it immediately struck a chord both for Dominic and also for me. Dominic, he has a background in environmental engineering. So actually this is a topic that is very close to his heart. In my case, I had experience working in data sets looking at carbon emissions, and also I'm very interested in this topic. So actually had a lot of energy and a lot of passion about investigating on this topic, which I think it helped. we didn't know very much about what exactly we were going to be doing or exactly what data we would find and the challenges we found there. But I think that that curiosity kept us going. And at the end, we ended up, the project was about developing a web application that was a visual dashboard. It allows to observe the changes that happen in air quality in the world in different cities in 2020. So the presentation outline, I'm going to be talking a little bit about the background. What are the data sources and the methodology that was used? Then I'm going to talk about a little bit under the hood, what is the components of the application. And at the end, I'm going to be showing you kind of a quick live demo of the application we developed to wrap up with some conclusions and findings. So the data set that we used comes from an organization called the World Air Quality Index Project. This is a nonprofit organization started in 2007 in Beijing, and it now has many supporters around the world. Its mission is to promote air pollution awareness by providing a free, unified, worldwide air quality information. So this data set is available for anyone who wants to do studies. They have real-time and historical data for about 30,000 stations around the world. The data set that we used for this study is a special aggregation that they have prepared for COVID-19 studies. Apparently, this type of studies that we're doing was very popular during 2020. So actually, they ended up preparing this data set, which is already a special aggregation. The data set is already organized, cleaned up, and we already have kind of a daily average measurements per city. So we do not have to deal with the problem of aggregating multiple weather stations from within a city. They provide the CSV files for the different years, ranging from 2015 to 2020. Actually, this is updated every month. And what you will find in each of these files is actually the 5 major pollutants commonly reported. The data covers 380 cities. And as I mentioned, it goes back to 2015. In total, when all this data is aggregated, we were handling a data set of about 500 to 600 megabytes. Unfortunately, our idea was to try to connect our application to a dynamic data set, which would be updated automatically in real time. Unfortunately, the APIs or the application interface to connect to this type of operations to historical data requires some form of payment or subscriptions. And especially Dominic, he spent some time looking at different APIs. And at the end, we didn't really want to spend money buying tools or subscriptions. So we ended up for now just downloading the data and working on static copies of the information. This diagram shows the workflow that we use to develop the application. For the data wrangling, the feature engineering, and some preliminary exploratory analysis, we used a free web app called Trifacta, which does basic data wrangling in a very easy, you don't need to code. It's all kind of a graphical tools where you don't need to write any code. The other one is Titka Spotfire that we use for some preliminary visualization. We use the free license version. For the construction of the visual dashboard and the web app, it was mostly built using Python. And we used a couple of special packages, the Streamlit for the web app interface and InfluxDB for database management. Then we used Heroku, which is a platform which allowed us to put our application out in the cloud for anyone to use. And we also, as a bonus, we learned how to work in Git. We were 3 people working on this application. So Anton, he created a repository where we would keep our files and the data, and we could send our changes and our updates to the program. He would come back with edits and comments. And basically it was a very interactive process and it worked fairly well. Then I'm going to start talking a bit about the 3 main components of our application: the data store, the web application interface, and how we did the cloud deployment. So for the database, we used a service called InfluxDB, which is a time series database platform. So the point here was, instead of keeping our data of 500-600 megabytes in memory, we decided to put it in a database. And this is a key consideration which was suggested by Anton regarding the app performance. Basically, we're trying to make it as lean as possible so actually the application can run faster. And what InfluxDB allows us is to put all our data into a server. So the application only makes queries to the database and gets the pieces of information it needs at a certain time for the dashboard. It does not need to load all the 500 or 600 megabytes in memory. The application, the version that we use is what is called the free plan. But it comes with a few limitations that are listed here. I'm just going to mention that one of them is the ability to write only 5 megabytes every 5 minutes, which of course it has an impact of how much data we can upload at a time, and especially during the testing, it was a little bit tedious. And I'm going to show you how we worked around with it. The second one is the data retention, which affected us. We have data dating back all the way to 2015. And the database, initially, we could only store up to 30 days of history. So what we did, the workarounds we devised for the 30 days historical data limitation, we ended up applying some kind of a workaround. We discovered that applying a transformation to the data, a 2000 days time shift into the future, actually InfluxDB could store the data and we could do the operations. The only thing is that every time we did a query, we needed to remove the time shift in order to use it, but that was very, very fast and it worked fairly well. Regarding the other limitation, the 5 megabytes upload every 5 minutes, actually, we ended up at the moment, it was just selecting a couple of countries out of the total, which fit into the 5 megabytes restriction. And it worked fairly well. We ended up uploading the data for 2 countries. It's a total of 67 cities, and we have the 5 channels for each of them, which are shown here. This is kind of the Data Explorer dashboard for InfluxDB, which allows us to interact and set some customizations on the database. The second component of our application, it was the web interface. And this was developed using a package called Streamlit. The Streamlit is a Python library that allows us to build web apps very easily. So we don't need to worry about coding, front-end development, because the Streamlit already has a library and handles those from Python without writing any specific code. So for this, I was just going to show you a quick example from our application, how we implemented some things in the dashboard. So here's a snapshot where we actually included a drop-down menu with the list of cities. The user has to click here and select one city, and the charts will be automatically updated. The way we implement this in our code is shown in the red box. Essentially, it's one command, which is this Streamlit select box command. It generates the drop-down menu, and the result, the input from the user, is stored in a variable that we can later use in the rest of the code. So it's very, very, very simple. The next component, it was about the cloud deployment. And for this, we used Heroku, which is a cloud deployment platform. Heroku is a platform as a service that is used for deploying and running web apps. Heroku gives our app a virtual machine to run on in the cloud. So the way it works, the developers ourselves, we created the code in Python. We tested, debugged it, and tried it in our computers, in our laptops. Once you're ready with the application, then you have to put it into what is called a container, or Heroku calls it dyno. Basically, each of these containers, of course, it has the application, the Python code that you have developed, but also it has all the environment, all the packages, libraries, all the information that you use to produce that code, and also even the operating system where that code was developed. So Heroku knows exactly when you give them the application, they know exactly what kind of virtual machine and what packages you're going to be needing. So the application runs on the web exactly the same way as it was running on your computer. Then the application is pushed to Heroku servers, and a link to the application is returned. This web link is something the users can click on it, and it will start the application, and they can start interacting with it. All they need to use the application is a web browser. For this Heroku, also we were using the free and hobby version, which also comes with some limitations. The first one is about the machines that we get for running our applications. You can see some degradation where you're running it on your desktop versus the web. We are getting machines with 0.5 gigabytes of RAM, which is not too much, but actually was very good for the project that we were running. It runs fairly fast, as you will see. The second one is this limitation on the time of inactivity. So actually, if our application has not been used for 30 minutes, it will be removed. So next time when you start the application, you need to be patient. It might take up to a minute to restart a virtual machine, to upload the application, the packages, and get it up and running. But for our purposes, this was okay. So now I'm gonna be doing a short demonstration of the web app. Here's a snapshot of the web app, and I'm gonna be clicking here. You guys, if you're interested, there's the address of the web application. Anybody can go and click on it. So basically, when you click on the app, what you will see is basically this window. There's some description about the project, the air quality check web app, and it has some sources and some information, especially about the air quality index project. One of the first things that you will see in this application is this map. This map shows the cities in circles, colored by the yearly change in pollution that happened during 2020. You can hover the mouse over the city, and it will show the name of it and the drop in pollution that happened over 2020. This map is interactive, so it can be dragged, it can be zoomed, and the changes in pollution that happen are expressed in a percent, which represents the change that happened in 2020 with respect to the average of the previous 4 years. The larger changes are shown in red colors, warm colors, and the smaller changes are shown in blue. You can click at any city, and there is a nice feature that will show kind of a breakdown. For instance, let's go, for instance, this city in China, Wuhan, it saw a drop in 2020 of about 28% in pollution. If you click on it, it will display a new chart showing on a monthly basis what was the drop that happened. So you can see that it was mostly happening during the first half of the year. Actually, there was a noticeable drop starting in January, and it reached its peak around March, and then you see that kind of winding down at the end of the year. It was almost zero, the difference. So you can do the same for every city, and you can compare the different patterns. For instance, we can go to Canada. We have cities here. We can click, let's say, on Edmonton. The change was smaller. It was like 11%. And we get kind of a similar picture. However, we see that the changes started happening later in the year, around March. And you have these kind of ups and downs. In general, these kind of changes tend to be associated with the lockdowns that each country started having around the world. Once you have explored cities in the map, you can go into more details. First, you have to select the city of interest from this drop-down menu. And we have the cities for Canada and China in this list. By default, I have selected Calgary. And there's a number of plots that are shown below that allows you to explore in a little bit more detail. The first one is a line plot. And the line plot has daily values of air pollution for every year. So you can easily compare one year. Let's select 2020. This is how the daily data looks in terms of this air pollution metric. And you can select other years and you can compare them one by one as needed. The second chart, it has the same information, but this time the year 2020, also daily data, is shown in red. In the background, we have this gray shaded area, which is again the 4 previous years, but this time they are aggregated for a 95% confidence interval using bootstrapping. So you can quickly, at a glance, compare 2020 versus previous years for Calgary. And one of the nice features, we added here some kind of scroll bars. You can zoom in into the chart. And also you can pan it, so you can explore with more ease. And you can see exactly what was the air quality reported for Calgary in any day and compare it to the previous 4 years. The last tool that we created actually is kind of a bit more interactive. It allows to select actual measurements, and automatically you can drag a window. Let's select a couple of months during the spring, and you can automatically see the chart at the bottom, which is automatically updated. It calculates the average per year. So this is helpful. For instance, in this case, it's not very clear from the scatter plot that 2020 had lower pollution levels as opposed to the previous years. However, when you go to the bar chart and you look at the averages, this is kind of a more evident. And you can drag this window and move it across the year, during the year, and you can see how the differences change as you move. All the charts that I showed you right now are based on the NO2 metric, which is the nitrogen dioxide. There's a short description here pulled from Wikipedia, but actually you can select any other metric that is available in the air quality index project. So for instance, I can select PM25, which are the fine inhalable particles, and you can do exactly the same operations. Okay, I'm just gonna start then wrapping up this discussion, and I'm gonna start with some of the findings. At least for myself, when we started kind of looking at the data, I was surprised to see this huge seasonality effect present. This is also data for Calgary, and you can see that the pollution tends to increase a lot during the winter months, and then it decreases during the summer, the warmer months. And just if you research on internet, you will see that actually this is a very well-known effect, that pollution levels tend to rise during the winter. So it implied that some data processing for us, we had to compare years versus years, apples with apples. Otherwise, we would not be able to see the impact of COVID-19. So this was a kind of an interesting insight for us. The second one, it was that actually the changes in pollution, when you compare and look at the bigger cities versus the smaller ones, it looks like it's way, way more visible in cities, let's say like Wuhan, where actually it's very easy to observe the changes that happen in air pollution in the first few months as compared to the previous 4 years. However, if you go to cities like Calgary, basically the impact is not as evident. And probably you would need to go to use some of the tools that we built in our dashboard to actually make it more quantitative. This does not look kind of a very clear marked change. Okay, so in summary, this was a great opportunity to have some hands-on data science experience. We tried to answer the question about which cities improved in air quality the most during 2020. We built, for this purpose, a visual dashboard web application that is actually a link that anybody can use. During the way, we also learned about tools for this kind of software development, just kind of developing dashboards and machine learning models that not only reside in our desktops, but actually something that anyone could use. So we used InfluxDB, Streamlit, and Heroku. And of course, there's always some things that were left in our backlog, some things that we would like to continue doing more iterations to improve it, like introducing some machine learning air quality predictions. Also, we wanted to have some real-time dynamic data updates using APIs, and of course, be able to upload the full list of countries to have the full world map view. So we're very happy with the product. These things will need to be kind of ideas for further iteration. So with this, I conclude the presentation, but before that, I would like to thank again the SPE Calgary for organizing this. I think it was a very well done activity, and it really gave us kind of an opportunity to apply these skills. And I would also like especially thank Anton, our mentor, who donated his time, and we spent a lot of time really kind of looking at this problem and giving us ideas, and it was very valuable. I really appreciate it. So thank you to all for your attention.
Thank you so much, Luis, for that insightful presentation. We've got some questions in the chat box. Anton has actually answered some of them, but we have one here from Yasir. Did you do any cluster analysis on the data?
No, I think that was one of the the ideas that was left in the backlog. I think that this exercise and most of our time it was really kind of learning the mechanics about developing software, developing the application, really kind of learning these tools. I think that we were kind of thinking about having some kind of a machine learning models, and there is some published literature on that about predicting really the changes in weather. We didn't get to that, and yeah, so that's something that is in the kind of on the wish list for future iterations.
Oh, nice. Thank you so much, Luis and Anton as well, for answering questions in the background. This wraps up the presentation as well as the question session. Moving forward, I'll be launching a poll to gauge where attendees first learned about the Data Science Mentorship Program. This poll will be up for about 45 seconds. So there you go. Let us know where you first heard about the mentorship program. Okay, nice. I can see here that most of you actually heard of the mentorship program from the Calgary website. and then a mix and match of 21% on LinkedIn, as well as this is the first time. Oh wow, okay, which is so good. Anyways, I'm just going to run through a couple of just a summary of the Data Science Mentorship Program. But in the meantime, again, if you still have some questions around the program, you can actually use the Q&A chat box for that. So in a nutshell, the Data Science Mentorship Program is a joint project between the Young Professionals and the Data Science and Engineering Analytics Special Interest Group of SPE Calgary. The program was first launched in spring 2021 with 50 mentees and 15 mentors. With the overwhelming demand and positive feedback from past year's participants, we are continuing the program next year in spring 2022. The program's purpose is to provide practical and learning opportunities to students and professionals who are interested in learning and applying data science techniques in the energy industry with the guidance and support from industry experts. We also have seen people graduating from this program apply what they learn in their current positions, and some even leverage on their newfound skill to pivot their career in another direction. Regardless of where our mentors and mentees are in their career, we want to build a community together and share our passion for the energy industry and data science. So therefore, you are all very much invited to apply for the next installment of this mentorship program. Applications are already open, and the deadline to register your interest is on the 31st of December 2021. Okay, that being said, we've got some other questions here. One question is for Luis. Hi, Luis. Can you share some feedback about the master's program you took at U of C?
Okay, yeah. No, thanks. I took the program starting in 2019. It's kind of demanding. I was working at the time, but I was able to do it at the same time I was working. So I would work all day until 4 p.m. and I had to take the train to go to the university. Classes run almost every day from Monday through Thursday, from 5 p.m. to 8 p.m. It's kind of a very intense program. I think the quality, I think that at the time I was taking it, I started in 2019. They are still kind of tweaking. There are some courses, but I would say overall, the content is very up to the point. I think that they spent the first 2 semesters kind of covering foundations on statistics and Python programming and R. So I think that's kind of the core. I think it's good to have the personal experience exercises. And I'm not going to lie, I mean, it requires some really kind of a large commitment, especially if you're working at the same time, but it's feasible. The nice thing is that it's kind of a very condensed. It runs for, you can do the full program, the diploma. It's for 2 semesters. So we did the fall and the winter semester. The winter semester, the second semester is more kind of into specialized topics. So you go more into machine learning models, specific applications, neural networks. So basically it's kind of a visual design as well. And you have the opportunity to go into different specialties. You can go into biomedical analytics. You can do into business analytics, or in my case, it was more like the data science general program. So overall, I think that it was a very good experience for the masters. as well. I think that there's the opportunity the university offers. They have their own job portal. So actually you can apply for internship opportunities, which in my particular case, it was very helpful because when you're kind of trying to pivot your career from oil and gas into a new area, actually having kind of a first step at the door is very important. So actually I think that the internship opportunities are very helpful in this sense. And that's what opened later. They opened the door for me for the job that I'm having in the government. So yeah, I think in general it was a very positive experience. I'm very happy with the program. So feel free to connect if you want to learn a bit more in details about the program and the experience. Yeah, you can contact me, and I'll be glad to chat more about this.
Thank you so much, Luis, for that exhaustive response. The other question I have here is about the Data Science Mentorship Program. And I think I'll be able to answer this one. It says, when will the selection of candidates take place? So with the time frame we've set for the mentorship program, deadline for applications would be by December 31st. Afterwards, the selection process would start. So we're going to be using the whole of January for the selection process and get back to potential candidates. The program is scheduled to start in February. So you'll be hearing back in January. Okay, I think that's all the questions we have. And thank you so much, Louis and Anton, for presenting your ideas to all of us. It's actually been very inspiring. And if there are no any other questions, I would like to call this webinar a close. So thank you so much, everyone, for coming, and enjoy the rest of your day.
Yeah, thank you, guys. Thank you, Emmanuel.
All right, then.
Talk to you later.
Cheers.
Bye-bye.
Okay. Bye.